Welcome back, everyone. In this lecture, we are going to talk about compositions of trig functions and inverse trig functions. There's two cases for us to consider. The case where the inverse trig function is on the inside, like in sine of tangent inverse of x, and the case where the inverse trig function is on the outside, like tangent inverse of sine of x. We'll start in this half of the lecture by looking at the first case, where the inside function is the inverse trig function. And so what I'll do first is, in this sort of a scenario, let theta be that inverse trig function. And the reason that I'm doing that is because, of course, an inverse trig function gives me an angle as its output. So cosine inverse of 5/7, for example, should be an angle. So I've let theta, the angle, be cosine inverse of 5/7. Now, if it had been some other number rather than 5/7, if it had been root 2 over 2 or 0 or 1, then I would have been able to find the exact value of theta. Now, of course, if I can't do that, I still have an option available to me, which is draw my angle on the xy plane in standard position. Now, I remember that for cosine, we had restricted the domain to being in quadrants 1 and quadrant 2, to being between 0 and pi. And we also know that cosine is positive in quadrant 1 and negative in quadrant 2. And since we're looking for cosine inverse of something positive, well, then that must mean we must be in quadrant 1. So when I draw my angle theta, I'd be drawing it in quadrant 1. And then remember that what we did back in chapter 7 was to define our trig functions on the xy plane in standard position by taking an xy point on the terminal arm, and by using x and y and r, which is that distance from the point to the origin, that we were able to define our trig functions, sine, cosine, tangent, and all the rest. So once we've done that, once we've identified that we are in quadrant 1 and we're looking for theta to be cosine inverse of 5/7, well, then that means that cosine of theta should be 5/7. And remember how we define things in terms of x's, y's, and r's. Cosine of theta was defined as x over r. So now we know what x is, now we know what r is, and then finally we use the relationship r is square root of x squared plus y squared, or equivalently, r squared equals x squared plus y squared. We use that relationship to solve for the missing value, and here the missing value is the y value. Once we've done that, we can then evaluate the trig function, because we are looking for sine of cosine inverse of 5/7, and we said cosine inverse of 5/7, that's our angle theta. So really what we're looking for here is sine of theta. And we know that sine of theta is defined as y over r. And we found what y is, y being 2 root of 6, and r being 7. So now we are finished. 2 root of 6 over 7, that should be the value for what is sine of cosine inverse of 5/7. So let's do some more examples. First one we have here, cosine of sine inverse of negative root 2 over 2. So I'll start off by letting theta be sine inverse of negative root 2 over 2. A couple of things just to remind myself. Number one, that for the restricted domain for our sine function, we had restricted it to quadrants 1 and 4 between negative pi over 2 and pi over 2. We also know that in quadrant 1, sine is positive, and in quadrant 4, sine is negative. And what we're looking for, of course, is sine inverse of negative root 2 over 2, so we know already that our angle must be in quadrant 4. Now, the next part here, of course, is to recognize that if we're looking for sine inverse of negative root 2 over 2, that's a number hopefully that's become very familiar to us, because we know that in the 45, 90 triangles where the side lengths are 1, 1, and root 2, that sine of pi over 4 is root 2 over 2, or 1 over root 2. So that means that the reference angle that we're talking about here should be pi over 4. In other words, we must be talking about negative pi over 4. That must be the angle that we're talking about. That must be what theta is. So I will say then that theta is negative pi over 4. And now, once I know that, I'm most of the way there, because remember, we were looking for cosine of sine inverse of negative root 2 over 2, but sine inverse of negative root 2 over 2 is the same thing as theta. So really, all we're looking for now is cosine of theta. And that's easy enough for us to do, because if we're looking for cosine of theta, that would be cosine of negative pi over 4. And here I'm going to use the even-odd properties of cosine to make my job a little bit faster. Remember, cosine is an even function. Cosine of a negative angle is the same thing as cosine of that positive angle. Cos of negative pi over 4 is the same thing as cos of pi over 4. And that's because cosine is even. Now, for cosine of pi over 4, returning back to our special triangle for pi over 4, cosine of pi over 4 would be adjacent over hypotenuse, 1 over root 2, or root 2 over 2. And so there we go. We have our answer of root 2 over 2. So final conclusion that I would say is that cosine of sine inverse of negative root 2 over 2 is root 2 over 2. All right, great. Let's do another example. Here we're looking for tangent of cosine inverse of negative 6/13. And I already know negative 6/13, that is not a number that comes from a special triangle. So firstly, I'm defining theta to be cosine inverse of negative 6/13. And secondly, I'm going to think about my quadrant. Remember that for cosine, we defined the cosine function as having that restricted domain of from 0 to pi. So in other words, quadrants 1 and quadrant 2. We also know that it's in quadrant 1 where cosine is positive and quadrant 2 where cosine is negative. And since we're looking for cosine inverse of negative 6/13, well, that means our angle must be in quadrant 2. So I will draw an angle in quadrant 2. There we go. That's my angle theta. And I also know that I'll have a point on the terminal arm, an XY point, and we'll talk about that in just a minute. Here we know that if theta is cos inverse of negative 6/13, then that means that cos of theta is negative 6/13. Returning it from a cosine inverse to a cosine, we're just switching inputs and outputs. And remember that cosine was defined as being x over r, so that means we know that the x-coordinate here should be negative 6. We don't know what the y-coordinate is, so that's the one thing that we'll need to find. And we also know that the value of r is 13. So the next job here is to find the missing value, to find the value of y. And this is where I'll use the relationship that x squared plus y squared is equal to r squared. And so we have x squared, or negative 6 squared, plus y squared equals 13 squared, or r squared. And then just simplifying a little bit, bringing the 36 to the other side gives us 133. And now at the next part, we're going to be taking a square root, and the question is, are we taking the positive root or are we taking the negative root of 133? And so this is where we need to go back and take a look at our sketch of our angle. And our angle was drawn in quadrant 2. And in quadrant 2, our y value is positive. We're above the x-axis. So that means that when we're taking our square root, we're not going to be taking the negative square root. We want the y value to be positive. We're taking the positive root of 133. Okay, so now we're ready to go. We know what x is, we know what y is, we know what r is. And to return to the original question, the question was, what is tangent of cosine inverse of negative 6/13? So what is tangent of cosine inverse of negative 6/13? Remember that cosine inverse of negative 6/13, that's our angle theta, where x was negative 6 and where y was root of 133 and where r was 13. Remember that tangent, which is the function that we're looking at now, is defined as being y over x. And we've got both of those things. We know what y is and we know what x is. Y is root of 133 and x was negative 6. So our answer is negative root of 133 over 6. I'm just going to write that a little bit nicer. Negative root 133 over 6. And there we go. We've evaluated tangent of cosine inverse of negative 6/13. I think this is a good spot for us to take a pause. So have a few minutes to relax, make yourself a fresh cup of tea. When we come back, we'll do one more example where the inverse function is on the inside, and then we'll start looking at what happens if the inverse trig function is on the outside.